Hello everyone, I'm Preethi Santhanam. Thanks for coming today. I'm going to talk about research work, scraping sticky leftovers, app user information left on servers after account deletion. So this work is a collaboration between my colleagues at Wichita State University and New Jersey Institute of Technology. To begin with, let me give a short introduction about the background. So according to our observation, around 65% of apps require users to create mobile app accounts for offering full-fledged functionality. While creating a mobile app account, users need to enter a lot of private information such as email address, phone number, or even social security number or banking information. So unfortunately, once this information has been gathered, only very few apps or companies provide the users to delete or forget the user's information, such as by providing a delete account button via app or website. So our concern is this leftover account data that is kept on the server after the account deletion, which can be a significant privacy violation because the leftover data can be manipulated and even be hacked by third-party users. We denote this leftover account information as LAI, that is the user's private data that is kept on the server after the account deletion or uninstallation process. LAI is problematic for two reasons. The first is LAI poses security risks because when the user's information is retained, it can be manipulated and leaked. The second reason is that it violates users' trust because after the successful account deletion process, the users reasonably expect or believe that the account will be permanently deleted. But most of the apps routinely violate these assumptions. Presented here is an example of the Pinion app where the user initiates to create an account by entering information such as name, password, birth date, and gender. After the user initiates to delete the account, the app asks for the user's confirmation. And after the account deletion process, when the user tries to create the account using the same account information, the app shows a warning message indicating that the account cannot be created because the email address already exists in the database. This constitutes to leftover account information because after the successful account deletion process, the information has to be permanently deleted, but which doesn't happen here. The last image is an example of the eBay website where after the 30-day post-retention period policy, the user's information is still retained on the server under the name anonymized, which also constitutes to leftover account information problem. So let's see how the account lifecycle works. As we are focusing on the Android apps, let's say the user wants to install an app from the Google Play Store. The first step he'll be doing is that the installation. And then the user will sign up for an account where the user's account information will be sent to the app servers and it is stored in the account database. When the user wants to log in or sign in, the information that is stored in the account database is used for the login or sign-in purpose. When the user no longer wants to use the app, he either plans to delete it or uninstall it. During this phase, what the user reasonably expects is that there will be an account deletion functionality provided in the app or website, or a retention period policy that states how long the user's information will be retained on the server, or the account should be permanently deleted after the successful account deletion process or after the retention period policy expires. But most of the apps routinely violate these assumptions, leading to 4 categories of leftover account information problem. So the first category is apps or website without no account deletion functionality. So if an app or website do not provide the users to delete the account, which means they do not provide the delete account button in the app or website via button or link, then this constitutes to leftover account information problem. The second category is a leftover account after deletion. If an app or website retains users' information on the server after the account deletion process, then this also retains users' information. The third category is leftover account after uninstallation. So if an app or website retains users' information after the uninstallation process, this also leads to leftover problem. The last category is no account retention period. If an app or website after the account deletion process doesn't delete the user's information and also does not indicate how long the user's information will be retained, this also leads to leftover account information problem. To address the challenges of leftover account information problem, we have developed a tool chain where it consists of 4 tools. The first tool is Account Deletion Analyzer. So Account Deletion Analyzer employs static analysis and automatically determines if an app or website provides account deletion functionality via a button or link. The second tool is Retention Period Analyzer. Retention Period Analyzer also employs static analysis and automatically determines if an app or website provides retention period policy. The third tool is a Leftover Account Analyzer. Leftover Account Analyzer automatically identifies whether the user's information is retained on the server after the account installation or deletion process. It employs dynamic analysis and analyzes both the APKs and websites. The last tool is a leftover account cleaner. Leftover account cleaner automatically deletes all the user's account after the uninstallation process. Let's see about each of these tools in detail in the next slides. The first tool is account deletion analyzer. So as we just saw, account deletion analyzer automatically determines whether the user's information, whether an app or website provides account deletion functionality where the user can delete the account. According to our observation, the delete account button or similar has some kind of text associated with the account deletion process, and in Android apps, the button clicks are usually associated with an action listener, which actually performs a delete operation. Then the GUI layout hierarchy, which contains text to explain the consequences or steps of the account deletion process. Account deletion analysis consists of 4 steps. The first is finding account deletion strings, then mapping strings to screen, finding action listeners, and then determining account deletion functionality. Finding account deletion strings. So this step involves a precise approach for automatically extracting the account deletion strings. But this step was challenging due to 3 reasons. The first is a simple regular expression did not work out. So we had to come up with a context-free grammar for automatically recognizing the AD strings. The second is that since strings are scattered in hundreds of files such as XML files, small files, or even HTML files for websites, it was a complicated process to first manually analyze all these files and then come up with an automated approach. The third reason is that since strings are also embedded in images, we have to first convert the images to text and then analyze the text for the account deletion string identification. For strings that match the patterns, a natural language processing algorithm was used to automatically extract the account deletion strings. Presented here is a grammar for finding account deletion string, where AD string is a combination of a verb phrase and a noun phrase, where the verb phrase contains a verb part of the account deletion string, which contains keywords such as delete, destroy, close, terminate, and then the noun phrase indicates a noun part of the AD string, which contains information related to account or registration information. The second step is mapping strings to screens. So there is a disconnect between the account deletion strings definition and its usage, where exactly these AD strings are shown to the user in the graphical user interface. Since AD strings are scattered in hundreds of files, we cannot directly connect the AD strings to its screen. So we have to map multiple intermediate steps in order to connect the strings to screen. So here we can see there are 3 account deletion strings which are mapped to its corresponding name attributes. Name attributes is then mapped to the layout, layout to the top layout to the fragment, and then the fragment is finally mapped to its corresponding activity, which is the graphical user interface the user sees in his Android app. So from this, we can conclude that the account deletion string has been mapped to its corresponding activity. The third step is finding account deletion listeners. So in Android apps, GUI actions are passed to the app code via action listeners. So if this action listener can be traced to one of the account deletion component ID numbers, we can conclude that account deletion functionality has been found. The last step is determining account deletion functionality. So account deletion functionality is determined by 2 conditions. First, a layout needs to be associated with an action listener, which shows text with account deletion semantics. And on the same screen, there are also other GUI components which contains text with account deletion semantics. So presented here is an example for determining ADF. It is an example of an app called IM, where we can see there are 3 text views which contains text associated to account deletion process that satisfies condition 2. And there is also a button that is corresponding to the account deletion process, which is associated to a callback function, which satisfies condition 1. From this, we can conclude that IAM app has delete account functionality in its app. The second tool is retention period analyzer. So what exactly is a retention period string? So when the user clicks on the delete account button, if an app does not delete the user's information and shows some kind of retention period policy stating that the user's information will be deleted after 10 days or 45 minutes or 30 days, then this specific time period is called as a retention period policy. Our tool, retention period analyzer, automatically extracts this retention period strings from the app or website. But the text needs to meet 2 conditions. This also follows the same procedure as that of finding account deletion strings in the account deletion analyzer tool. First, the text must contain strings with account deletion or account restoring semantics. Second is that the text must contain a time period string consisting of a number and a time unit. So the third tool is a leftover account analyzer. Leftover account analyzer automatically determines if the user's information is retained on the server after the account deletion or uninstallation process. Leftover account analyzer runs on a laptop where the Android device is connected to it via Android Bridge. It is completely an automated approach, and it employs dynamic analysis where we used APM server, which issues commands directly on the device. We manually collected word sets that are responsible for the sign up, automatic deletion, and re-sign up phase. But the manual intervention was needed in 3 scenarios where the app used CAPTCHAs and during confirmation prompts or verification of email address or phone numbers. It was a hybrid approach during this process. So this account analyzer consists of 4 steps, where the first step is the initial sign-up phase, where the account analyzer automatically installs the app from the Google Play Store, finds the sign-up screen, and supplies required information that are needed for the automatic sign-up, and it creates a new account until successful sign-up is confirmed. So the GUI elements to the text input mappings are also logged, which are key fields for the LAI detection. The second step is account deletion. So if the leftover account analyzer automatically deletes the account from the app or website, but it invokes some of the account deletion analyzer modules to determine if an app or website has an account deletion functionality. If an app or website has an account deletion functionality, then the leftover account analyzer performs a workflow by logging in automatically and finding the account deletion functionality and then automatically deleting the account. The third step is repeating the sign-up process. Leftover account analyzer uninstalls app automatically and again installs app from the Google Play Store, attempts to repeat the sign-up process by again entering the required sign-up information until successful sign-up is confirmed. So if the user's information is still retained on the server, we'll get warning messages indicating that the email address or user's information is still retained on the server. From this, we can conclude that, okay, the information is still retained on the server. The last step is verification of leftover account information. So all the fields that you entered while creating an account are retained on the app's backend servers. But how do we verify this? Since we do not have access to the app's backend servers, finding these retained fields from the app's backend servers is infeasible. For this, we developed an approach where we showed 3 scenarios and identified the interactions between the user, app or website, and then the backend server. So here, the user initiates to create an account, which is communicated to the app backend server via API function. And then when the user initiates to update the account, it is also communicated from the app or website to the backend server via API function. When the user finally initiates to delete the user account, so now here, if there is an API function that is corresponding to the account deletion process, we can say that the app or website has communicated to the backend server to delete the user's information. From this, we can conclude that yes, the user's information is not retained on the app's backend servers. So this is the first scenario that we identified from our high-level approach. And then in the second scenario, again, the user creates an account, which is also communicated to the backend server, updates the account, then finally initiates to delete the user account. So here, we don't find the API function corresponding to the account deletion process, which means the user's information is still retained on the server. The last scenario is that when the user initiates to delete the user account, there is an API function that deletes the user's age, but still the user's location is still retained on the server, which means some fields are deleted and some fields are retained on the server. But how do we verify this leftover account information? For this process, we reverse engineered app backend server communication and identified the account manipulation operations, which means we identified methods or API functions that are responsible for the account creation, deletion, or updation. For this process, we decompiled APK files into small e files and extracted the methods responsible for the account deletion and updation operations. So most of the apps that uses software development kits employed backend servers. So here presented here are some of the API functions that we identified for the account creation, deletion, and updation operations. So the last tool is a leftover account cleaner. Leftover account cleaner automatically deletes a user's account after the account uninstallation process. This also runs on a laptop where the Android device is connected to it via Android Bridge. Here, the first step is leftover account cleaner finds a list of uninstalled apps as the set difference between the apps in the account history on the Google Play Store and the apps currently installed on the phone. Second step is it reinstalls an uninstalled app by downloading it from the Google Play Store. The last step is it automatically finds the ADF button, logs in, automatically deletes the account. Then the evaluation results. So we analyzed 1,435 apps from the Google Play Store, and we only focused on the apps that had own sign-in process, which means sign-in using email, and we did not focus on apps that provided sign-in using third parties such as Google or Facebook. From that, we identified that 254 apps retained users' information after account uninstallation, and 17 apps retained users' information after account deletion, and 437 apps did not have any ADF buttons. And table 7 shows some of the retained fields on the server, where government ID and banking information being the sensitive information are the least retained information, and the most retained information are the first name, username, and phone number. Our approach detected and indicated that our toolchain was effective, resulting in an F measure of 88.4%. And regarding the efficiency results, leftover account analyzer took a median time of around 162.68 seconds, where the maximum time taken by the tool was during the reinstallation phase, that is the re-signing up phase. And then the account deletion analyzer took a median time of around 275.78 seconds, and the maximum time was during the image to text conversion phase. The retention period analyzer also took the median time of around 259.03 seconds, and the leftover account cleaner took a median time of around 231.29 seconds. Thank you. Questions?
All right, we have some time for questions. If anyone wants to ask questions, please come to the mic. Maybe I'll get started. I think the examples you gave at the beginning were with eBay and
Pinion app?
Yeah, so did you report? What did they say?
Yeah, we contacted the customer service, and they said that they will retain some of the users' information for their research, something like that. But we do not know what kind of information is retained from their side.
Did you contact their lawyers?
Yeah. No, we just contacted the customer service.
Nice talk, Shilin from RIT.
Thank you.
So I'm wondering, in the process of finding the API for the account creation or deletion, are you looking on the smiley code, right? The
Sorry.
smiley code of the APK file?
Yes.
So how do we handle the obfuscation in the code?
Yeah. So since we do not have access to the app backend server to delete the account, we decompile the APK files and then find the API functions that are responsible for the account deletion operations, where the actual deletion operation happens between the communication between the app or website and the backend server. So we extract these methods that are responsible for the account deletion operation.
Okay, thank you.
Yeah.
Hey, that was a really nice talk. I was just curious if you've considered this study in the context of privacy regulations like the CCPA or GDPR, which require some type of deletion process from some of these apps, or is that something you've thought about?
Not exactly, but
Okay.
like the apps, we did have a look at the app's privacy policy. They say that they do not retain users' information. But after the account deletion process or the retention period policy ended, we contacted them. They said that the information will be deleted, but which doesn't happen. We checked after even like 5 to 6 months. And they said, yes, we retain some of the users' information for future research.
Got it.
Yeah.
All right. Thank you.
Thank you.
All right. Well, thanks a lot, Preethi. Let's thank the speaker again.